Okay, so here we have a picture of the unit circle. Now, we know that on the unit circle, the radius is 1. So we've learned about all these points here where the circle intersects the axis. I'm going to draw in an angle, and really I could put this angle anywhere, but I'm just going to put it in quadrant 1 to make things a little easier for ourselves. So we always start in the positive x-axis, and there we have our angle, and it's intersecting the unit circle here at the point x comma y. Okay, we're going to call that theta, and remember that the radius of the unit circle is always 1. So what I'm going to do is I'm going to ask you what the sine of theta is. When you're thinking about sine, you're thinking about the opposite side over the hypotenuse. Now, in order to create this, I'm just going to drop this here and make a right triangle. The length of this leg is x and the length of this leg is y. So if I want to know the sine of theta, I just look there and I say, well, y is the side opposite and the hypotenuse is 1. If I wanted the cosine of theta, I would say, well, adjacent is the x and the hypotenuse is 1. So now what we've shown is that sine equals y in our picture and cosine of the angle equals x. Now we've been working with that for a while, so we know that the point here is cosine comma sine. Okay? If I asked you for tangent of the angle, you would tell me that that is opposite over adjacent. So now we've just proven that tangent is sine over cosine. Okay, but these are things that you already know, so I'm going to prove something a little bit different to you today. Now, if I take this triangle here, if I take this triangle and I use the Pythagorean theorem on this triangle, I'm going to get that the side squared plus the side squared equals the hypotenuse squared, right? Or leg squared plus leg squared equals hypotenuse squared. Or x squared plus y squared equals r squared. Okay? Now, this is just another use of the Pythagorean theorem using x, y, and r instead of a, b, and c. But what I have here is that x was cosine, y was sine, and r was 1. So this is what we call a trigonometric identity because it is true for all values of theta. So for any value for theta, if you just plug into sine squared plus cosine squared, you're going to get 1 every single time. And you can say cosine squared plus sine squared, but that's the same thing as sine squared plus cosine squared. So what we're going to be doing in this unit is working with angles on the unit circle and trigonometric identities.